Okay, today we're talking about Chapter 3, Section 1, the Cartesian coordinate system, scatter plots, and the linear equations. Alrighty, so there's a lot to unpack here at the beginning of this section. Um, I'm going to snip all this, but the main points are going to be our figure here. So let's do that. There's our Cartesian coordinate system, our figure. Make sure we don't have anything else to go with it. Okay. Alrighty, I'll try to follow along with the text and just kind of go in order here. So here's the figure associated with our in bold are going to be our definitions, our terms, things that we're going to see. I say we, things that I still see. Well, obviously I teach math, I know, but this is a very, very important system of graphing that you have probably used before, and you're going to be using the rest of the time that you're in college. It doesn't matter if you're going for a business degree or mathematics degree, you're going to see this. All right, so let's start off with the concept of an ordered pair. Ordered pairs are written in the form x, y, okay, where x is some number and y is just some number. Right? The x is going to correspond with how far left or right I travel on the horizontal line, and y is going to indicate how far I go down or up on the y-axis. All right. All right. So for example, let's consider the equation y is equal to 3x plus 1 and the ordered pair 2, 7. Okay. So 2 is the x and 7 is the y. So if we plugged in 2 for x, we end up with y is equal to 7. So therefore, 2, 7 is going to be a solution, or it satisfies the equation. Right? So 2 is the x, 2 is the x, 7 is the y. We plug in 2 into our equation, and if we get y is equal to our number 7, then we see that 2, 7 does indeed satisfy this equation. So the first number we're going to call the first coordinate, or the x coordinate, and the second number 7 is going to be called the second coordinate, or the y coordinate. The ordered pair is not the same as the ordered pair, the ordered pair 2, 7 is not the same as the ordered pair 7, 2 because the order of numbers is not the same. Right? Also, 7, 2 does not satisfy the equation because if I plug a 7 in for x, 3 times 7 is 21 plus 1 is 22, and that is not equal to 2. Okay. And then we're going to talk about the actual Cartesian plane here. All right, for the first bold, we have quadrants. Okay, so each one of these little box areas you can see here are called quadrants. All right, quad being 4, so there's 4 quadrants. And you read them from the top right, and you rotate around counterclockwise. So quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. You rotate around counterclockwise. Right here in the middle of the graph is called the origin. The origin's coordinate is 0, 0. The horizontal line here we call the x-axis, and the vertical line we call the y-axis. The x-axis, as we go to the right, are positive x values. As we go to the left, are negative x values. Again, this is coming from the origin. And from the origin, as I go up, the y values are positive, and as I go down, the y values are negative. So let's take a look at point B real quick. Point B is 5, 2. So in order to plot that point, we have to go to the right 5 units because we're told, the point is 5. Go to the right 5 units on the x-axis and then up 2 on the y-axis. Right. So that makes it a positive 5, positive 2. Now let's look over here at A. Right. A is negative 1, 3. So if it's a negative 1, that means you're going left on the x-axis. So we go left on the x-axis 1 and then up 3 units on the y-axis. So we have a 3 there. Well, yeah, let's go and look at C. C, I guess it's just really driving the point home that you can plot anything. So square root of 2, the negative square root of 2 and 2. So we're going left the value of the negative square root of 2, and they're going to go down 2. And of course, we can see that for all of these. Okay. Furthermore, notice how we have plus plus here, minus here, minus minus here, and plus minus here. That's basically indicating the value, or I'm sorry, not the value, but the sign of the points, right? Here in this first quadrant, they're both positive. Here in the second quadrant, only the first number is negative. Here in the third quadrant, both numbers are negative. And here in the fourth quadrant, only the y value is negative. One thing that I didn't mention, though, was points that are on the axes, right? Here on the y-axis, we have the point 0, right? Because we're moving, we're not moving left or right any value. So it's a 0 for the x and a -4 for the y. So we just go down 4 units on the y-axis. Whereas over here, it's 7, 0. So we move to the right 7 units on the x-axis, but we don't move up or down on the y-axis at all, 0 units. Right? So that's a crash course on the Cartesian coordinate system. All right, maybe we'll put this on there as well. All right, so graphing ordered pairs, and I wish I had a blank one. We'll snip this and just talk about it though. Cause I mean, honestly, realistically, I guess my graphs tend to be a little wonky on this tablet, anyways. All right, so example one, we're asked to graph the set of ordered pairs. All right, so we have the ordered pairs. They are named A, B, C, D, and E, and we need to graph them. And here are the points. All right, the points are right here in the parentheses. So starting with A, we have the point -3, 1. So this tells me that I'm going to be going left on the x-axis 3 units, and then up 1 on the y-axis. That's what we see here. We go left 1, 2, 3, and then up 1. Right, and of course, we can follow along down here if you need to. But B is -3, -1. So I'm going to be going left on the x-axis 1 unit and down 3 on the y-axis. So I'm going to be going left 1 and then down 3. 1, 2, 3. C is a little tricky, right? It's 0, 2, so I'm not moving left or right at all. All right, I'm staying at the origin for the x value, so that stays. But my y axis or my y value is a 2, so I'm going to be going up 2 units. So I'm not going anywhere from the origin, and I'm going to be going up 2 units. 1, 2. That's how we see that point. D1, 5. Again, 1 for the x, 5 for the y. I go to the right 1, and then up 5. 1, 2, 3, 4, 5. And then E, 2, -4. I'm going to the left. I'm sorry, go to the right 2. 1, 2, and then going down 4. 1, 2, 3, 4. That's how we graph ordered pairs. All right, so this reads, the graph of two straight lines are given. Each line contains an infinite number of points. Use the grid to help you locate or estimate 3 points on each line. Okay, so let's make this one large as well. All right, so when it says it has infinite points, it's true. I can come up with an infinite amount of points on this line. The thing is, for example, notice how this, maybe is, so this looks like it's about halfway from 0 to 1, right? On the x-axis, this blue line. Okay. Well, I could say 0.5x, and then I could come up with an infinite amount of y's. Well, not from the 0.5x, but I can come up with an infinite amount of x's and y's just based off that. However, we're going to make this a little bit easier on our eyeballs, and we're going to look for things that for points like this point where it lines up nice and neatly. And so when I say like this point, notice how it lines up nice and neatly here with that. Okay, it lines up nice and neatly with the square. So let's just start with that point. That point looks like I'm going to be going over 3 units and up 1, 2, 3, 4, 5, 5. Okay, so it looks like 3, 5 is a point. So 3, 3, 5. There we go. Looks like 3, 5 is the point. Where else do we line? Oh, it looks like we line up pretty nicely right here. So it looks like I'm going left. I'm sorry, I'm going right. I keep getting my left and right mixed up. I'm going right 2 units, and then I'm going to be going up 1, 2, 3 units. So it looks like positive 2 and positive 3. Positive 2 and positive 3 is another point. Let's get out of the first quadrant. Let's go down here and see if we can't find anything down here. This looks like it lines up nice and neatly. It looks like we're going to be going left. Finally, I got that right? Going left 2 units and down 1, 2, 3, 4, 5. So we're going left, so that means we're going to say negative 2, and we're also going down, so we're going to say negative 5. Okay, and let's actually go ahead and mark those. So 3, 5, 1, 2, 3. So 3, 5 was right here. 2, 3, 1, 2, 1, 2, 3 was right here. And then negative 2, 1, 2, 3, 4. And then negative 2, negative 5 is right here. Okay, so we're just going to mark that right there. And I'm curious what the textbook used. Negative 1, negative 3, 0, 1, 0, 1, 0. Oh, sorry. Man, I'm having a rough go here. 0, negative 1 is indeed a point, and then 3, 5. Okay, so 3, 5 is the only one we really had at the same time. All right, so next up, let's do B. All right, so B looks like here's a good point. Let's just go ahead and call this one a point, and let's do this one as well. All right, and then going from the top to bottom, up here, looks like I'm going left 1, 2 units, and 1, 2, 3, 4, 5. So negative 2, positive 5. All right, this point right here is on the y-axis, right? So I'm not going left or right at all, so it's 0, and then I'm going up 2. And then this point looks like I'm going to be going right 2 units, and then down 1 unit, so that's going to be a negative 1. Right? So we just read some points on a graph there. Okay, scatter plots. We'll just give it its own page. Alrighty, so in statistics, data is sometimes given in the form of ordered pairs. We call those paired data, where each ordered pair represents 2 pieces of information about one situation. So for example, ordered pairs might represent the height and weight of a person, or the minutes a student studied and the grade they earned on an exam. The ordered pairs are plotted on a graph, and the graph is called a scatter diagram or a scatter plot. Scatter plots are used to determine whether there is any pattern to the data. If there is a pattern, then the scatter plot can be used to predict the value for one of the variables when the value of the other variable is unknown. So, for example, if you know that person's height is 5'6", then his or her weight might be predicted from the information indicated in a scatter diagram that has several points of known information about height and weight. So kind of like an average, right? And I'm sure many of you might have started seeing scatter plots pop up left and right, especially from COVID. All right, so example 3 reads, the table gives estimated budget and opening weekend sales of top opening movies. Right, and we don't have a name in the movies. Okay, so that's cool. I was really kind of curious there, but okay. All right, so A reads, rewrite the data in the table as ordered pairs in the form of budget and opening sales. Okay, so we're going to be going absolutely crazy with ordered pairs here. And this says use the data to create a scatter plot. Huh. Okay, so that's going to be a lot of work. But here we go. We're just going to do A first because A seems like it's probably going to take up. So obviously, we're going to do A first. We're going to do A alone on this page because this looks like it's going to take up a lot of space. So in order to create ordered pairs, it doesn't really get too much easier than this. This is going to be X, and then this is going to be the Y. This is X, so this is Y, and we're just going to go crazy here. Okay, so first thing, we're just going to start going. We're going to say 321 and 257. 245, 248. Huh. All right, well, I still end up running out of room there. Let's move this to the left a tad. There we go. Perfect, okay. And then 150, 208, 220, 207, where are we at? 200. I'm losing track of everything right now. 200, 207, and hopefully you see what I'm doing. And I mean, it's just this is some crazy busy work right here. 250, 191, 200, 182, 250. Oops, don't want that. 179, 160, 174, and then lastly, if I hopefully I covered everything, 200 and 174. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Uh-oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What? 2, 4, 6, 8, 10. Oh no, I doubled up somewhere. Alright, so let's see. 150, 220, 200. Oh. 2. I don't know where I doubled up at. Let's look at this. So 34, 150, 208, 220, 207, 200, 202. Okay, so this one, there is no 200 and 207. This one does not exist. 200, 202, 250, 191, 200, 182, 250, 179, 160, 174, and all right, there we go. That one did not exist. That was a mix of two of them. That was an accident. Okay. And so that was the uh, rewriting the data in ordered pairs. And if we're going to, I am just going to go ahead and snip this chart, mainly because in your homework you're going to have a nice pretty graph to snip, not snip it, but snap to points. Whereas me, on the other hand, I would have to, you know, plot them and just kind of eyeball it. So we're going to just put this down and we're going to talk about it though. Okay, so B. Alright, so we need to create a scatter plot. So the way we do this is we just start from the top, 321, 257. So we go over here to about 321 on the x-axis, and then we go up to about 257 on the y-axis. And we do that for every one of them, right? 245, 248. We go over here to about 245, and then we go up here to about 248. And we do that for all of these. And that's really just that's it. We just plot the points. Alright, so Alright, so next up we have finding ordered pairs that satisfy linear equations. So let us consider the equation in two variables, 3x plus y, and that's equal to some 3, or not some 3, that does equal to 3. Alright, and if we solve for y, okay, we subtracted 3x from both sides, we end up with y is equal to a negative 3x plus 3. The solution set to this equation consists of an infinite set of ordered pairs, and again, infinite set because there are an infinite amount of solutions to this problem of ordered pairs in the form x, y. The variable x is called the independent variable, and the variable y is called the dependent variable. All right, so how do we remember independent and dependent? Well, your x, you can choose your x just independently, right? You can say, okay, 9, right? And then when you plug 9 into this, well, negative 3 times 9 is negative 27, plus 3 is negative 24, and that's what your y is. Your y is dependent on your independent variable. Right, so that kind of makes sense there. A definition here, the solution set of an equation in two variables x, y consists of all ordered pairs of real numbers x, y that satisfy the equation. Right, and of course we see examples of all these points here, 1, 2, 3, 4, 5, all 5 of these points, right, they satisfy this equation. Right? Now again, there's an infinite amount of these solutions, but these are just the ones that the textbook decided to choose. Right? And it says choices, x. Right? We choose x, right? It's independent. We plug in this particular case, negative 1 right here, 0 here, 2/3 here, 2 here, and 3 here. We choose x because it's an independent variable. We substitute it in, and then we solve. We just do the arithmetic, right? Negative 3 times a negative 1 is a positive 3. Positive 3 plus 3 is a 6. And 6 is your y value, right? Because it is dependent on your x value. And since you plugged in a negative 1 and you got out a 6, that is a point that you plot. And you can see that for all the others as well. All right, so lots of definitions and stuff here. Alrighty, so starting from the top on the left here, just as we use the term ordered pair and point interchangeably, we use the term equation and graph of an equation interchangeably. So the equations, 2x plus 3y is equal to 4, y is equal to negative 5, x equal to 1.4, and y is equal to 3x plus 2, they're called linear equations. All right, now real quickly, linear, right? Linear, the first 4 letters there are line. Well, they are L-I-N-E, right? Which spell line. And all of these equations create a line. Okay? So the standard form of a linear equation is in the form of ax plus by is equal to c. Some a connected to an x, some b connected to a y, and then we have just a c, which is a just any value. Okay, and it could also be 0 also as well, right? As long as they are real numbers. The note here, in standard form, ax plus by is equal to c. A and b may be positive, negative, or 0, but a and b cannot both be 0. Okay, why can they both not be 0? Well, if we plugged in a 0 for for a and a 0 for b, well, 0 times x is 0, plus 0 times y is 0. We get 0 is equal to c, so c must be equal to 0. So we basically don't even have an equation, right? If a and b are 0, we don't have an equation. That's why that says that. So every line corresponds to some linear equation, and the graph of every linear equation is a line. We know from geometry that 2 points determine a line. This means that the graph of a linear equation can be found by locating any 2 points that satisfy the equation. So once again, we have a procedure to graph a line, and you are more than welcome to follow that procedure, but I like to teach in a way where I simply just speak aloud, right? So see if I can try to not take the graph with me. Right, this time I will graph this, and I know I had a square. I had a square tool one time. Where in the world is it? Maybe this help me? No. All right, sorry. Right now I'm looking for a square tool. So I can make a nice pretty square, but I don't think it's going to happen. All right, so instead we're just gonna have to make a Cartesian plane here. It's not terrible. Luckily it does snap. Is that straight? I'm leaning to the side here. All right. So we have our lines, and let's go ahead and mark. So y is equal to 2x. Maybe we'll just do 5. Okay. So this reads, it says graph y is equal to 2x, right? So in this particular case, what we're going to do is we're just going to make a chart here. Let's make it in yellow actually. Just kind of differentiate the colors a little bit. Right? We're going to have an x and we're going to have our y's. Okay. And so let's just start with a -2. Okay. So if we plug in a -2, we're going to do some mental math here. Okay. So if we plug in a -2 right here for x, all right, well 2 times -2 is a -4. So we have -4. Let's plug in a 0. When we plug in a 0 for x, we have 2 times 0, which is 0. So y is equal to 0. So that's cool. Go right through the origin. And realistically, we can stop right there. Okay, because you only need 2 points to create a line. But we're going to go one more, and let's do 2, positive 2 here. Okay, well if we plug in a positive 2 in for x, well 2 times 2 is 4, and so that's where we get the y from. So now let's plot these points. All right, well the first one's pretty easy. Well, it's actually the second one, but the second one being the origin, 0, 0, we plotted that point. Then we have a -2, -4, so we're going to go to the left, 1, 2, and down 4, 1, 2, 3, 4. So that's the point I'm going to plot right there. And then a +2, 1, 2, and up 4, 1, 2, 3, 4. So that's the point I'm going to plot right there. Right. And then we just connect this line. Let's see if we can't connect it nice and pretty like. Oh no. Okay. That was not good. Let's try that again. There we go. There we go. We'll do it like this. Okay, we'll see, and this is why I don't graph too often, right? Because well, it looks like that. But that is how we graph that equation, and I'll snip this just to make sure you have a nice pretty graph to look at on your notes. Right? Same thing, just this is a lot nicer and neater and obviously more precise. Next up, right? So again, like I said, we really only need to plot, or we really only need to find 2 points, right? Since this is a linear equation, you know that any 2 points create a line. So let's go ahead and create our coordinate plane real quick. And let's do the whole 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, and 5. Okay. And we'll do our little plot over here. X, Y. All right, so let's go ahead and take this equation and solve it for y. I don't think we're getting there yet. Yeah, we can solve this for y. Okay, so let's just go ahead and solve this for y really quickly, and then I'm going to erase it, right? So we're going to have 2x plus 3y is equal to 6. I'm going to subtract 2x from both sides, so if I subtract 2x here, and I subtract 2x over here, that ends up as a 3y is equal to a -2x plus 6. I'm putting my x first because We really need to get used to that sort of notation because we're gonna be doing that. I don't know if we're gonna do it quite often in this class, but definitely gonna be doing that a lot in the next class. Okay. And then we divide both sides by 3. So we're going to say y is equal to a negative 2/3 plus 6 over 3 is 2. Okay, so real quickly, all I did there was I obviously divided the left side by 3. The right side I divided by 3. But I can split that up into something look like this. That's where I get negative 2/3 x and then 2. So let's go ahead and erase all this and put this new equation up here because it'll make it a lot easier when we do the computation. So we have y is equal to negative 2/3 x plus 2. All right. And we don't even need that big because we're only going to pick 2 numbers, right? Well, the first number I'm going to choose is 0. 0 is always the winner here. All right, so I'm going to plug in a 0 for x. Okay, so if I plug in a 0 for x right here, well, 2 times 0 is 0. 0 plus 2 is 2. And so we have y is equal to 2. So that's 1 point. And let's just go ahead and plot it. It's going to be right here at 0, 2. The next number I'm going to choose a 3. And the reason I'm going to choose a 3 is because notice if this is a 3, well, let's see, if this x is a 3, then the 3's just cancel, right? Negative 2/3 times 3, the 3's cancel, so I end up with a negative 2 plus 2. So I'm choosing a number there that gets rid of the fraction. I don't like fractions. Again, I've been doing this many years. I still hate fractions, and you will probably not like fractions either. But we plug in a we plug in a 3 for x. We get back a 0 for y. So let's plot that. So we go over to 3, and we just plot that. And that's it. Again, that's all we need, and we just go through, and that's it. Okay. And again, I'm going to give you the nice pretty graph here. And there we go. All right. Next up, and I think this is actually the last one here. Excuse me. Maybe not. I guess we have, yeah, we have 7. Okay. So graphing a linear equation, same deal. Not much different here, except this time that they don't change it over to the equation like I did. So I'm going to go ahead and not pin, but kind of just give you that graph as well. Okay, so like I said on the previous example, and also in the textbook, we'll go back and look at it. In the textbook, they didn't rearrange the equation, right? Whereas I did, because I feel like it makes it easier. Well, example 6 doesn't rearrange the equation and just kind of keeps it in the exact same equation that you see. And oh, that's interesting. Okay, so hey, wow, this actually worked out pretty nicely. So I snipped all this with hopes of, hey, this is it. Here you go. But it looks like I can just fill in these blanks. Alrighty. So I've got I'm going to go ahead and do it. If I'm plugging in these values for x, well, what the heck's going on? Solve the equation for x and substitute. Okay, so I'm substituting values in for y. 0, 1, and 2. Okay, so if I'm going to be substituting in these values for y, 0, 1, and 2, well, if I plug in, and let's make it a little bit larger so I have a little bit more room to work here. Maybe that might help. Okay, so if I plug in a 0, and then they want a 1, and oh, that's not a good one, and a 1 and a 2 for y. And again, we see we're just plugging in to the y in that equation. Okay. Well, this actually is the same as well. We just plug in 0, 1, and 2. Well, we see that we have the x be 1, y is 0. We have that point 1, 0. X is 3, y is 1. We have the point 3, 1. X is 5, y is 2. We have the point 5, 2. So that was actually a super duper easy exercise, and if I were you as a student, I'd hope my entire homework looked like that. I'm just kidding. No, honestly, I would though. I am no stranger to easy tasks. I like easy tasks. Okay, intercepts. Okay, so I don't know why I thought we had 6 exercises, because we still have intercepts to talk about. Alrighty, so the big deal about intercepts, I don't necessarily have to read all this time, because this really sums it up pretty nicely. Okay, so to find the y-intercept, we need to substitute x equals 0 for y. Right? Now that doesn't sound too intuitive, I know, but think about it like this: if I'm trying to find the y-intercept, if I'm trying to find where I'm crossing the y-axis, oh, by the way, I think maybe I should have read over there. The x-intercept is where we intercept the x-axis, right? Where we cross the x-axis. We cross it right here. The y-intercept is where we cross the y-axis. We cross it up here. So those are our intercepts. So sorry about that. I kind of forgot that. But if I want to find my y-intercept, I set x equal to 0. And if I want to find my x-intercept, I set y equal to 0. Again, it does not sound that intuitive, because you would think, it's not as poetic as if you want to find the y-intercept, set y equal to 0. If you want to find the x-intercept, set x equal to 0. Right? It doesn't make sense though, because if you recall, the y-intercept is where I don't move left or right on the x-axis. So that's why I have to put 0 in for x. And if you recall, my x-intercept is where I don't move up or down on the y-axis. So I have to put a 0 in for y. So just remember, you're doing it, kind of backwards, right? You're going to find the y-intercept, you set x equal to 0. You're going to find the x-intercept, you set y equal to 0. So it says graph x plus 3y is equal to 9 by locating the y-intercept and x-intercepts. Okay, so this is not going to be too hard. So let's go ahead and start off with, let's say, we're going to say the x-intercept. So x-intercept. All right, so in order to find the x-intercept, I have to set y equal to 0. So I'm going to say x plus 3 times 0. All right, I'm just setting my y equal to 0 is equal to 9. And I've got x is equal to 9. 9. Okay, so that means my point is, all right, x is equal to 9, which is what we got, and we made y be 0. So that's my point, 9, 0. My y-intercept. So my y-intercept, I set x equal to 0. So 0 plus 3y is equal to 9. All right, well, we obviously have a 3y is equal to 9. And then we divide both sides by 3. So we have y is equal to 3. Okay, so same kind of thing here. We made, and let's actually go ahead and let's do it like this, just to really drive the point home. Right. We made the x equal to be 0, so we're putting a 0 there. And the y we got out was a 3. Okay. Now they're wanting us to also graph this. Well, I'm going to give you the graph with just the intercepts. Okay, and again, all you need is 2 points, right? And this does it nice and neatly. Right. My y-intercept was 0, 3, so that's my point there. My x-intercept was 9, 0, put it there, and I just connected the dots. That's it. All right, just find the x-intercepts, find the y-intercepts, and then you can graph. Okay, so same thing here. X-intercept, so put X int. We set Y equal to 0, so we're going to have a 3x minus 2 times y, which is going to be 0. And that's going to be equal to 12. So we have a 3x equal to 12. We divide both sides by 4. We end up with x is equal to 4. Right. So again, my x value here is a 4. My y value is the value that I gave it, which is a 0. So 4, 0 would be my x-intercept. My y-intercept, right, I set x equal to 0. So I've got 3 times 0 minus 2y is equal to 12. Okay, well, I end up with a negative 2y is equal to 12. I divide both sides by negative 2, so I have y is equal to a negative 6. So again, my x, I gave it the value of 0, and I got out the value of negative 6. So these are my ordered pairs for my graph. And then I plot those points, and here we go. Nice, pretty graph. Let's put this note in there because I think it's pretty good. Right. And that concludes today's lecture.